Yes. Yes, good morning students. In the last class we discussed about the introduction and velocity or rate of the chemical reaction. Now next one is types of rate of reactions. Types of rate of reactions. Types of rate of reactions. Rate of a reaction. Rate of a reaction. Types of rate of a reaction. Whatever rate of a chemical reaction or velocity of a chemical reaction, it is nothing but the rate at which the molar concentration of the reactant decreases per unit time, or the rate at which the molar concentration of the product that increases per unit time, because across the reactant side the molar concentration or concentration of the reactant decreases, across product side the concentration of the product gradually increases. In case of gaseous system, the concentration is expressed in terms of the pressure, whereas in case of the fluid masses, we are expressing in terms of molar concentration. That is obtained according to the law of mass action. According to the law of mass action, rate or velocity of a chemical reaction that is directly proportional to the molar concentration of the reactant, provided a temperature of the system is constant. Now types of a chemical reaction. Chemical reactions are classified. Rate of a chemical reaction is classified into two types. First one is average velocity or average rate of a reaction. 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 And second one is instantaneous rate of a reaction. Instantaneous rate of a reaction. Instantaneous rate of a reaction. Average rate of a reaction and instantaneous rate of a reaction. Now, average rate of a reaction that depends upon the change in molar concentration of the reactant or change in molar concentration of the product and the time interval, that's the difference in the time that is involved in bring about that change. These are the various types of the chemical reaction. Now come one by one. That is the average rate of a reaction. Average rate of a reaction. Average rate of a reaction is directly proportional to the change in concentration of the. Now come one by one. That is the average rate of a reaction. Average rate of a reaction. It is represented by R average. or average. This is R, or average. Instantaneous rate of a chemical reaction is represented as R instantaneous. Whereas average rate of a reaction is directly proportional. It depends upon the change in concentration of the reactant, 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 especially that is in terms of moles per liter, change in moles per liter, or change in concentration of the product, change in concentration of the product, change in concentration of the product. That is also expressed in terms of the same unit, that is in terms of moles per liter. Change in concentration of the product, but also in terms of moles per liter. And also it depends upon time taken for the change of the chemical reaction. The time taken for the change of the chemical reaction, and time taken for that change, that is given by means of delta T, which is equal to T2 minus T1, that is the final divided by initial. It depends upon the two factors, average rate of a chemical reaction or R average, that depends upon two factors. The first factor is change in concentration of the reactant or change in concentration of the product, and also it depends upon the time taken for that change. Consider a chemical reaction. Consider a chemical reaction. Consider a chemical reaction as R gives rise to product. Consider a chemical reaction, R gives rise to product. What do you mean by R? That is, R is equal to reactant, and P is equal to product. R is equal to the reactant and P is equal to product. R is equal to reactant and P is equal to product. Whereas the velocity or rate of the chemical reaction is given by R average. R average is given by, see, across the reactant side, the concentration of the reactant that decreases. Across the reactant side, the concentration of the reactant that decreases. Whereas that is given by, R2 minus R1, R2 divided by R1 divided by R2 divided by R1 divided by T2 minus T1, T2 minus T1, T2 minus T1, T2 minus T1, T2 minus T1. What do you mean by R2, R1 and T2 and T1? This is given by means of delta R. This is given by means of minus delta R divided by delta T. This is given by minus delta R divided by delta T. What do you mean by delta R? Where is R2 minus R1? Where is R2 minus R1? After the bracket, that is a 2 and 1, not inside the bracket. That is given by means of delta R. Whereas the T2 minus T1, that is given by means of delta T. T2 minus T1, that is given by means of delta T. Is it clear? What do you mean by R2? That is the final concentration of the reactant. or the concentration of the reactant at an instant of time t2. What is my R1? R1 is the initial concentration of the reactant at an instant of time t1. At an instant of time t1, you have to specify R2 and R1, whereas molar concentration of the reactant at T2 and R1 is molar concentration of the reactant at T1, whereas R2 is equal to molar concentration of the reactant molar concentration of the reactant at T2, molar concentration of the reactant at T2, whereas the R1 that is equal to molar concentration of the reactant molar concentration of the reactant at T1, molar concentration of the reactant at T1. Is it clear? This is with respect to the product. Now, what is the negative sign implies? What is the negative sign that implies? What is this very important negative sign? This negative sign implies decrease in molar concentration of the reactant. Negative sign indicates, this is very important. Negative sign indicates decrease in molar concentration of the reactant. Decrease in molar concentration of the reactant. Is it clear? This is R average of the chemical reaction with respect to the reactant, considering the reactant. Even we can consider the product also. R average is equal to, this is very important. That is R average is equal to minus delta R divided by delta T. R average is equal to minus delta R divided by delta T. Now, one more. R average is equal to average rate in terms of products. Average rate in terms of products. R average is equal to, that is a plus, that is a P2 minus P1 divided by T2 minus T1. T2 minus T1. That is given by this plus delta P divided by delta T. Delta P divided by delta T. That is the product concentration minus reactant concentration. What do you mean by P2? What do you mean by P2? That is where P2 after big bracket 2, P2 is equal to molar concentration of the product, molar concentration of the product, molar concentration of the product, molar concentration of the product at T2, molar concentration of the product at T2. There is a P1 is equal to molar concentration of the product, 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 molar concentration of the product at T1, molar concentration of the product at T1. Molar concentration of the product at T1. Now P2 significance is over, P1 significance is over, T2 significance is over, and T1 significance is over. There is a plus sign indicates, very important, plus sign indicates, plus sign indicates increase in molar concentration of the product, increase in molar concentration of the, increase in molar concentration of the product, molar concentration of the product. This is about the symbolical significance of plus minus R1, R2, P1, P2, T1 and T2. Based upon this, we have to solve the problems. And hence, where is the decrease in concentration of the reactant divided by unit time? Now the average rate of the chemical reaction. This is about the average rate of the chemical reaction in terms of the reactant and average rate of the chemical reaction in terms of the product. Okay. Therefore, average rate of a chemical reaction is given by average rate of a chemical reaction is given by average rate of a chemical reaction is equal to, therefore, or average rate of a chemical reaction is equal to change in molar concentration of the reactant divided by time taken. Change in molar concentration of the reactant, change in molar concentration of the reactant divided by time taken, divided by time. This is very important. Change in molar concentration of the reactant divided by time taken. This is the very important formula. Now, instantaneous rate of a chemical reaction. Next one is instantaneous rate of a chemical reaction. instantaneous rate of a reaction, instantaneous rate of a reaction, instantaneous rate of a reaction. This is second one. Instantaneous rate of a chemical reaction is second one. Average rate of a chemical reaction is first one. Instantaneous rate of a chemical reaction is second one. Instantaneous, it is over a specified period of time. It is at particular time. That is a instantaneous time. It is average rate of a chemical reaction can be defined as the rate of a chemical reaction at specified time. Whereas here this is instantaneous time. Whereas the specified word is there, here the instant word is there. Over a period of time is there, here the particular time is here. Particular time is here. Rate of a chemical reaction, rate of a chemical reaction. It is defined as the change in the concentration of a reactant or product at a particular instant of time. It is at a particular instant of time. Very important. At a particular instant of time. At a particular instant of time. At a particular. This is very important word. Change in concentration, rate of a chemical reaction, rate of a chemical reaction, or change in concentration of reactant. Instantaneous rate of a reaction, instantaneous rate of a reaction, instantaneous rate of a reaction, rate of a reaction is defined as change in concentration of the reactant or product. Change in concentration of the reactant, change in concentration of the reactant, concentration of the reactant, concentration of the reactant or product, or product. Or product at a particular instant of time. At a particular instant of time. At a particular instant of time. This is very important. At a particular instant of time. What is the average or velocity of a chemical reaction? Average velocity or average rate of a chemical reaction is defined as change in concentration of the reactant or product under a specified period of time. It is a particular instant of time. Now, how it is obtained? Particular instant of time, that is obtained by means of by plotting the graph of the average velocity of the chemical reaction and draw tangent to the slope, tangent to the graph, and at a particular instant of time then you can obtain that graph that indicates at a particular instant of time t that refers to the instantaneous rate of a chemical reaction, instantaneous rate of a chemical reaction. Whereas instantaneous rate is equal to instantaneous. It is given by means of instantaneous rate of a chemical reaction, instantaneous rate of a reaction, instantaneous rate of a reaction. It is given by means of R instantaneous is given by means of R instantaneous. It is given by means of average rate of a chemical reaction, average rate of a reaction, average rate of a reaction, average rate of a reaction, under limit delta t tends towards 0, 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 limit delta t tends towards 0. Therefore R instantaneous is given by, therefore R instantaneous reaction is given by, R instantaneous rate of a chemical reaction is given by means of, that is average rate of a chemical reaction limit tends towards 0. Suppose with respect to the reactant side, that you know that minus delta R divided by delta T, minus delta R divided by delta T, when minus delta R divided by delta T, when minus delta R divided by delta T, minus delta R divided by delta T, whenever this limit delta T tends towards 0, delta T tends towards 0, this can be written as minus dr by dt, minus dr divided by dt, minus dr divided by dt. That is a decrease in molar concentration of the reactant with respect to dt, decrease in molar concentration of the reactant, whereas D stands for decrease in concentration of the reactant to the decrease in time or change in time. That minus sign indicates with respect to the reactant, there is a plus sign that indicates with respect to the product. Therefore R instantaneous is mathematically is given by means with respect to the reactant, that is, you know that this is instantaneous chemical reaction, this is average rate of a chemical reaction, there is a minus delta R divided by delta T, that is the average rate of a chemical reaction. Whenever it is an average rate of a chemical reaction, please remember here you have the delta. Whenever the instantaneous is there, there is a D, that is the difference between instantaneous rate of a chemical reaction and with respect to the average rate of a chemical reaction with respect to the instantaneous rate of a chemical reaction. In average rate of a chemical reaction, we have delta term is there. In instantaneous rate of a chemical reaction, you have D term is there. Okay, whenever that's delta R divided by delta T, delta R divided by delta T, when limit delta T tends to 0, then that is equal to minus dr divided by dt, minus dr divided by dt. That is with respect to the reactant side, with respect to the reactant side. With respect to the product side, whereas R instantaneous is given by with respect to the product side. Yes, instantaneous rate of a chemical reaction with respect to product, instantaneous rate of a chemical reaction with respect to product. Instantaneous rate of reaction, instantaneous rate of reaction with respect to product, with respect to product, instantaneous rate of reaction with respect to product, with respect to product. That is R instantaneous is equal to plus delta P divided by delta T, delta T divided by delta T, limit delta T tends towards 0, delta T tends towards 0. This is given by means of plus dP divided by dt, plus dP divided by dt. See, in instantaneous chemical reaction you have D term, in average velocity you have delta term. What about the significance of the plus, minus and dP and dt like this? Whereas plus sign indicates increase in the molar concentration of the reactant, whereas the dP stands for, there is a small difference in the change in the product concentration, and dt stands for at an instantaneous time t, at an instantaneous time t. Okay, now this is the notation. Therefore R instantaneous is given by, R instantaneous is given by minus dr divided by dt, minus dr divided by dt, that is with respect to reactant, with respect to reactant. And R instantaneous is given by plus dP divided by dt, plus dP divided by dt, that is with respect to product, with respect to product. respect to product. With respect to product. Now, very important, instantaneous rate can be determined graphically instantaneously. This is very important. Instantaneous rate. Instantaneous rate is obtained graphically. Instantaneous rate can be obtained. Instantaneous rate can be obtained graphically. Can be obtained graphically. Instantaneous rate can be obtained graphically by drawing a tangent at a time t. By drawing tangent by drawing tangent at time t. Tangent time t on curves of reactant versus time. Reactant versus time or product versus time. Reactant versus time or product versus time, and calculating its slope. And calculating its slope. Slope means a tan theta. Calculating its slope. Okay, this is about the instantaneous rate of a chemical reaction and average rate of a chemical reaction. Now I will give the graphical representation of the average velocity and instant velocity of a chemical reaction. Now take the graphical representations. This is with respect to time t. This is concentration. concentration, that is in terms of moles per liter. This is in terms of second. This with respect to reactant, it is in decreasing order. With respect to reactant, it is decreasing order. Take any one of that, 2 points. Now draw the perpendicular line to the x-axis and y-axis. Suppose this is dy, or difference, this is dt. This is dt, this is dr. dy by dx. This is considered with respect to reactant, that is dr. That is in decreasing order. Then plot any at an instant of time t, therefore dy by dx. Assume that is a dy, this is a dx. Slope is equal to, assume this is a dy by dx, that is a tan theta. Suppose this is a theta, then slope is equal to tan theta. Slope is equal to opposite side divided by adjacent side. That is dy divided by dx, or that is equal to dr divided by dt. Here, at particular instant of time t is taken, is taken, that is called instantaneous. Therefore, rate is equal to minus slope. With respect to reactant, it is in decreasing order. With respect to reactant, it is decreasing order. This is instantaneous. This orange mark that refers to, that is a rate instantaneous. This is rate instantaneous. At any instant of time t you have to take. Now this is equal to, this is small difference, that is a delta t. This is small difference is the delta r. At when this is t is equal to 0, at instant of time t is equal to 0, then it is called instantaneous rate of a chemical reaction. This is with respect to the reactant side. Rate is equal to minus the slope. Now remember, rate here is equal to minus the slope of the chemical reaction. Now this is R instantaneous. Okay, this is with respect to the reactant side. Similarly, we can draw with respect to the product side also. Then to draw the product side, here this is concentration, this is the time. Where is the concentration of the product that increases? Therefore, here this is a time. This is concentration of the reactant, that is in terms of moles per liter. This is with respect to the second. Therefore, here concentration of the product that gradually increases. Concentration of the product that gradually increases. Then you plot a graph. You fix any point on these two curves. Suppose this point and this point, the perpendicular line, and join these two lines. Join these two lines. Join these two lines. Now this is called as a that is the tan theta. That is the slope is given by tan theta. This is the difference. This difference with respect to this time. That is equal to, suppose that dy by dx. This is equal to dy value. Suppose this is equal to dx value. That is positive slope. For the reactant side, that is negative slope. With respect to the product side, this is positive slope. Then keep any point at this graph, that is r instantaneous. Suppose we consider any point on this curve, that is considered as r instantaneous. That is equal to rate of the chemical reaction. Rate is equal to plus slope here. Here rate is equal to minus slope. Rate is equal to plus slope. Because product side that is equal to positive, at reactant side that is equal to negative. These are the graphs that indicates the average velocity and instantaneous velocity of the chemical reaction. Okay? Rate of a reaction in the form of stoichiometry of a chemical reaction. Rate of a reaction. Now solve the problems that based upon it. Solve the problems. In a chemical reaction, in a chemical change, A plus B gives rise to C plus T, comma, the concentration of A, concentration of A, the concentration of A at the commencement of at the commencement of 20th minute is 1.0012 moles per cubic decimeter. If the concentration falls to, if the concentration falls to 0.001 if the concentration falls to 1.00 moles per cubic decimeter. 1.00 moles per cubic decimeter. After 20 minutes 30 seconds. After 20 minutes 30 seconds. After 20 minutes 30 seconds. Calculate the average rate of the reaction. Calculate average rate of the reaction. 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 Okay. Dear students, it is the problem based upon the average rate of the chemical reaction. What is the formula of the average rate of the reaction? R average is equal to R average, that is equal to minus is only symbolically significant that I mentioned, that is R2 minus R1 divided by T2 minus T1 that I mentioned. Minus is only symbolical significance, but you have to calculate the R average. What is this R2 minus R1? Here R2, that is equal to R2 is equal to, that is the final concentration of the reactant. Final concentration of the reactant, that is found to be 1.00 moles per cubic decimeter, and R1 that is equal to 1.0012 moles per cubic decimeter. 12. Anyhow, that is the difference between these two values. Therefore, R2 minus R1 it seems to be R2 minus R1 seems to be minus becomes plus. Therefore, that is R1 minus R2. R1 minus R2. Therefore, here R1 minus R2 difference is equal to how much? R1 minus R2 difference, that is given by, that is a difference in the molar concentration of the reactant. Difference in the molar concentration of the corresponding change in molar concentration of the reactant. Corresponding change in molar concentration of the reactant. Corresponding change in molar concentration of the reactant. Molar concentration of the reactant. Molar concentration of the reactant. Molar concentration of the reactant, that is equal to 0.0012 moles per liter or moles per cubic decimeter. Moles per cubic decimeter. Is it clear? That is the numerator value. What about, say, at the commencement of 20th, that is a T2 minus T1 value. This is equal to R2 minus R1 value. This is R2 minus R1 value, which is seems to be R2 minus R1 value. R2 difference R1. That value is equal to this much. There is a T2 minus T1 difference. T2 minus T1 difference. That is the time interval. That is the specified time. See, this is the commencement of the 20th minute. This implies at the end of the 90th minute. End of the 90th minute to end of the 20th minute. After 20th minute, 30 seconds is here. Therefore, that seems to be 60 plus 30, total 90 seconds. No confusion. That is equal to 90 seconds. 90 seconds. After commencement of the 20th minute, when 90th minute over, then 20th minute starts. Then 20th minute starts, completion of the 20th minute, that is 60 seconds. Then 60 seconds plus 30 extra, that is 90 seconds. I will give the hint. Commencement of the 90th. Commencement of the 20th minute. Commencement of 20th minute means end of the 90th minute. End of the 90th minute. End of the 20th minute starts. 20th minute starts. 20th minute starts to end of 20th minute. End of 20th minute. End of 20th minute is equal to 60 second. Is equal to 60 second. Is equal to 60 second. This is very important. Then that 60 second here plus 30 second extra, that seems to be 90 second. Then substitute these values. That is equal to 0.0012 divided by 90. Divided by 90. Divided by 90. That seems to be how much? That seems to be how much? This is minus value. That seems to be minus value. This is in terms of moles per cubic decimeter divided by second. Divided by second. Simplify this value. It seems to be 1.33 into 10 to the power of minus 5. 1.33 into 10 to the power of minus 1.33 into 10 to the power of minus 5. That is moles per cubic decimeter per second. This is the unit. That is R average. R average. 1.33 into 10 to the power of minus 5 moles per cubic decimeter per second. Okay. Thank you, students. I will continue the next session.